Hello everyone, my name is Nidhi Singh. I am assistant professor in Gyan Vihar School of Pharmacy, that is a part of the Suresh Gyan Vihar University. So today we are going to discuss the topic that is the aliphatic amines that comes in your first unit with carboxylic acid, and this comes in pharmaceutical organic chemistry first in second semester. So let's start the topic. So here we are going to discuss about the amines, that what are amines and what are aliphatic amines and what are the study about, and also we are going to study about the classification of amines, that what are the classification of amines and how many types of this amine is, and also we are going to study about the physical properties and characteristics of amines and the nomenclature, and we also discuss about the nomenclature, that how we can name aliphatic amines and what are amines, what are aliphatic amines, and what is its physical property, that what is its boiling point, what is physical, which state it is present, and what is the characteristic of this amine. And there, what is the basicity of this amines. Secondly, student outcomes. The student outcome, they will be going to know about what are amines, and also they are going to learn about the classification of amines. They will also learn about the physical properties and basicity of amines. So overall, this topic contains that what are your amines, um, how we can name them, how we can classify them on the basis of their amine ammonia group that is attached to them, and how we can what are the physical property and the characteristic of this amine is. So let's start. So aliphatic amines are the derivative of ammonia in which one or more hydrogen atoms have been replaced by alkyl group. So this aliphatic amines, these are the derivative. These ammonia, as you know, that ammonia has a structure that is NH3. So this ammonia, so these aliphatic amines, so this aliphatic amines, these are the derivative. These are the derivative of this ammonia in which one or more hydrogen atoms have been replaced by alkyl group. So in this, in the ammonia structure, where hydrogens are attached to it, which means in ammonia there are three hydrogens are attached to it. In this aliphatic amines, form the aliphatic amines, this ammonia, from this ammonia, the hydrogen atoms attached to this ammonia have been replaced by the alkyl group. So alkyl group, so firstly you can see here that this is the structure of this ammonia. Secondly, methylamine, that is CH3, NH2. Third, dimethylamine, CH3 whole twice NH, trimethylamine, that is CH3 whole twice, and in which no hydrogen atoms are attached to it. So this shows that these aliphatic amines, these are the derivatives of ammonia in which one or more hydrogen atoms have been replaced by alkyl group. So next is your classification of amines. So these amines are classified into three forms. And first is a primary, that is a 1 degree. Second is a secondary, that is a 2 degree. And third is a tertiary amines. So here, these amines are classified as primary, secondary, tertiary amines, depending on whether one, two, or three, all the three atoms, all the three hydrogen atoms of ammonia molecules are replaced by alkyl group. And thus the characteristic groups are respectively of primary, secondary, and tertiary amines are like this. So amines are classified as primary, secondary, and tertiary amines, and depending upon whether one, two, or three hydrogen atom of ammonia are replaced by alkyl groups. So these amines, which are classified as primary, secondary, tertiary amines, depending. Means here in the ammonia group, there are three hydrogen atoms are attached. So the classification of amines are based on that ammonia structure in which the three hydrogen atoms are attached. So if these classifications based on depending whether there is a replacement of one hydrogen or there is a replacement of two hydrogen by the alkyl group or the hydrogen replaced by the alkyl group. So thus the characteristic groups are respectively of primary, secondary, tertiary. So here amino is your primary and imino is your secondary and nitrile is your tertiary. So here aliphatic amines. So again, aliphatic amines are the derivative of ammonia in which one or two hydrogen atoms have been replaced by alkyl group. So this amines are the derivative. Means these aliphatic here means that they are containing the chain not the aromatic means the aromatic contains the phenyl ring with them. So in this case, the aliphatic here means that they are containing a chain of hydrocarbons with them. So the amines which are containing the chain of hydrocarbon in them that are known as your aliphatic amines. And these aliphatic amines, these are the derivative of your ammonia in which one or more hydrogen atoms have been replaced by alkyl. So these aliphatic amines, which are the derivative of ammonia, in this aliphatic amines, in this the hydrogen atoms from the ammonia have been replaced by the alkyl groups. So here you can see the ammonia structure that is NH3. So here methylamine. So here in this methylamine, you can see one hydrogen is replaced by your one alkyl group. Second, in case of dimethylamine, you can see that these two hydrogen atoms have been replaced by your two alkyl groups. And third it is your trimethylamine. In the trimethylamine, your three, three hydrogen atoms have been replaced by your alkyl group. So this is your trimethylamine. So the next is your classification of amine. So in the classification of amine, the amines are classified as primary, secondary, and tertiary amine. So in the classification of this amine, so in the classification of amine, this is based on it is depends upon the classification of amines depends upon whether there is a one replacement of hydrogen atom or two replacement of hydrogen atom or a three replacement of hydrogen atom by this alkyl group. So those are the characteristic groups. So these are the characteristic groups in which here shown the replacement of hydrogen atom. So here you can see in the amino there is the there is a replacement of one hydrogen atom. There is a replacement of one hydrogen atom from this amino, and in the imino case, you can see there is a replacement of two hydrogen atoms, and in the nitrile, you can see there is a replacement of three hydrogen atoms. That is why they are named according to the replacement of the hydrogen atoms of ammonia molecules that are replaced by the alkyl group. On that basis, they are classified as primary, which is the amino, secondary, imino, and tertiary is the nitrite. On that basis, these are classified, these aliphatic amines are classified, and these are aliphatic amines are these aliphatic amines are the um, derivative of your ammonia. From this ammonia, they are formed. They are uh, they are formed from the ammonia, and in this, from the ammonia, there is a replacement of this hydrogen from a replacement of hydrogen by your alkyl group. So that are known as your aliphatic amines and transferred as primary, secondary, tertiary on the basis of their replacement of hydrogen atom by the alkyl group. Next is your primary amines. So what are the primary amines? So in primary amines, only one of the hydrogen atoms in the ammonia molecule has been replaced. That means that the formula for the primary amine will be RNH2, where R is an alkyl or aryl group. So in this primary amine, here you can see that in the primary amine, there is only one hydrogen atom. There is only one hydrogen atom in the molecule. Only one hydrogen atom in the molecule. Ammonia molecule have been replaced. So that means that the formula of the primary amine will be NH2, where R is an alkyl or aryl group. So in this primary amine, as you can see, there is a structure of this primary amine group, and in this NH2, there is a two lone pair is shown on this nitrogen, and it is having the two hydrogen atom, and one hydrogen atom has been replaced by the alkyl group. So this alkyl group has been present here due to the replacement, due to the removal of the hydrogen atom. So here, this is the formula for the primary amine. And here R is then your alkyl, or it can be your aryl group. So it is your alkyl group, it can be your aryl group or your alkyl group. So here this is your 1-amino propane. So this is the example which is showing the primary amine. So this is your NH2. So NH2 means here that this is your amino. This is your primary amine because this one hydrogen has been replaced by this alkyl chain. That is your CH3, CH2, CH2. So this alkyl chain is your R. R is an alkyl or an aryl group. So this is a propyl group that is attached to this primary amine, where one hydrogen has been replaced, by your this alkyl chain. This alkyl chain. This is your formula amine. So it can be named as your 1, 2, 3 carbon atoms are there, and this is your nitrogen group. And on the one position, this NH2 is attached to this carbon on the first position. That is why it is named as 1-amino propane. In the second case, you can see here it is your 2-amino propanes. In this case, this amino group is attached to the second carbon atom. That is why it is named as 2-amino propane. This is your 2-amino propane, and this is the formula for the primary amine group. This is the formula for the primary amine group, and in primary amine, only one of the hydrogen atom in the ammonia molecule has been replaced. This is the first step of this. This is the first type of your aliphatic amine, and in your primary amine, this only one of the hydrogen atoms in the ammonia molecule has been replaced, and that means that the formula of the primary amine will be RNH2, where R is an alkyl or your aryl group. So in this CH3, CH2, CH2, NH2, in this its name is 1-amino propane because on the first position of this carbon atom, this amine is attached. So its name is 1-amino propane. Second is the CH3, CH, NH2, CH3. So in this you can see on the second position, this amino group is amino propane is attached. So its name is 2-amino propane, and this is the formula for writing this primary amine. So second is the secondary amine. So this is the second classification of this this aliphatic amine, and in the secondary amine, two of the hydrogen in an ammonia molecule and have been replaced by alkyl or aryl group or both. So in this case, you can see this is the CH3 and HCH3. So in this, this is on the second On this nitrogen is having one hydrogen, and the two hydrogens have been replaced by the two alkyl groups. So its name is dimethylamine. The two methyl groups, which are the alkyls that are attached to this nitrogen atom, and when one hydrogen is attached to it, so its name is dimethylamine. Secondly, CH3, CH2, NH, CH2, CH3. In this case, its name is diethylamine. So in this case, also, the ethyl alkyl that has been attached to this nitrogen atom, one hydrogen atom here, that's why its name is diethylamine. So here you can see the two side of this nitrogen is having the ethyl group, and that is why its name is diethylamine. So its formula is R1 NHR2, and its name is secondary amine group. This is your secondary amine. So first is your primary amine, second is your secondary amine. So in the secondary amine, you can see that the two hydrogen have been replaced by the two alkyl group, or you can say the two aryl group, or both, from both. Means one side you can attach the alkyl group, and on the other side you can attach the aryl group. So in this is the second most amine of this of this uh, of this aliphatic amine. So in this, two of the hydrogens in an ammonia molecule have been replaced by alkyl or aryl group, or both of them. Next is your tertiary amine. So in the tertiary amine, all of the hydrogen in an ammonia molecule have been replaced by hydrocarbon group, alkyl or aryl group, or both. So in the tertiary amine, that is your 3-degree amine, in this all the hydrogen and an ammonia molecule have been replaced by the hydrocarbon group, that is your alkyl or your aryl group. So in this you can see the here, this is the this is the structure for the trimethylamine. So here you can see the nitrogen is not having any hydrogen atom attached to it, because all the hydrogen atom have been replaced by your alkyl group. So that is why its name is trimethylamine. These three methyl groups are attached to this nitrogen. So its name is trimethylamine. So here this is the formula for this tertiary amine, that is 3-degree amine. So in this, you can see the nitrogen is having the pair of lone pair on it, and with R1, R2, R3 are the three alkyl group, or the three aryl group, or you can say that on the two structure, two R1 and R2, it is having the alkyl, and R3 is having the aryl, or you can say that this R1 is having the alkyl, and R2 and R3 are having the alkyl aryl group. So it can be formed by this, and this is a tertiary amine group, which comes third, and in the tertiary amine, all the hydrogen in an ammonia molecule have been replaced by the hydrogen group. The last is your quaternary amines. So in the quaternary amine, in quaternary ammonium cations, also known as quats, are positively charged polyatomic ions of the structure Nr plus 4, and R being an alkyl group or an aryl group, unlike the ammonium ions, that is your NH plus 4. So in the quaternary amines, quaternary ammonium cations, these are also known as quaternary ammonium cations, and these are also known as quats. So in this quats, these are positively charged. These quats are positively charged polyatomic ions of the structure that is having this Nr plus 4. Means on the nitrogen, there are 4 alkyl groups are attached, and R being an alkyl group or an aryl group, unlike the ammonium ion, that is your NH4. So here on this quaternary amine, as the name shows that in this there are 4 alkyl groups are attached, 4 alkyl groups are attached, and on the 4 alkyl group there are these 4 alkyl groups, it can be your alkyl groups or the aryl groups. So its formula is NR plus its formula is NR plus 4. So here 4 shows here that the 4R is your alkyl group or an aryl group or a mixture of both. And unlike the ammonium ion, it is having in the ammonium ion there is NH plus 4, but in this quaternary amine it is having NR plus 4. So the quaternary ammonium cations are permanently charged. So these quaternary ammonium cations, these are permanently charged independent of the pH of their solution. Quaternary ammonium salts are quaternary ammonium compounds or quaternary amines and oil-filled paramenses are salts of quaternary ammonium cations. These quaternary ammonium cations are permanently charged, means they are having the positive charge on it. So these cations means the positive charge is present on the ammonium molecule. So and quaternary means here the four or alkyl groups are attached to it. So the quaternary ammonium cations, these are permanently charged and these are independent of the pH of the solution. They are independent, they are not dependent on the pH of the solution, but they are independent of the pH of the solution. And the quaternary ammonium salts or quaternary ammonium compounds. These are the quaternary ammonium salts or the quaternary ammonium compounds. And these are also called quaternary amines in oil-filled parentheses. And these are also the salts of quaternary ammonium cation. These are also the salts of quaternary ammonium cation. So these are the quaternary amines. So again, in the tertiary amine, these are containing all the hydrogen and then ammonia have been replaced by the alkyl hydrocarbon group, that is the alkyl group or the aryl group, or you can say the both. So this shows the structures of the tertiary amine group. As you can say, the three alkyl group R1, R2, R3 are attached to this nitrogen, and there this dotted structure dotted shows that there are a lone pair of the electron are present on the nitrogen. And the example of this is trimethylamine, that is your CH3 and CH3 CH3. So here this is your trimethylamine. Next is your quaternary amines. So in the quaternary amines, quaternary ammonium cation, these quaternary ammonium cations also known as quats, and these quats are positively charged. These quats are positively charged polyatomic ions of the structure that is having Nr plus 4. So these are positively charged polyatomic ions, and this is having the structure that is a Nr plus 4, and R being an alkyl group or an aryl group, and unlike the ammonium ion. So ammonium ion is having the structure that is your NH plus 4, and this quaternary amine is having the structure that is your Nr plus 4. So the quaternary ammonium cations, these quaternary ammonium cations, these are permanently charged. These are permanently charged and independent, and these are not dependent on the pH of the solution. So they are independent, and these are also these names. These are also known as your quaternary ammonium salt, the quaternary ammonium compound. These quaternary ammonium salt or quaternary ammonium compounds, these are also the salts of this quaternary ammonium cations, which are known as quats. So these are the salts. These quaternary ammonium salts or the quaternary ammonium compounds. These are the salt, and in their parentheses, or the parentheses, these are called quaternary amines, and these are all are the salts of quaternary ammonium cation. Next is the natural nitrogen compounds. So these are the natural nitrogen compounds that the nature abounds with nitrogen compound, and many of which occur in plants and are referred to as alkaloids. So these are the natural nitrogen compounds, and these natural nitrogen compounds are referred as your alkaloids, and these are present in plants, and these are having the nitrogen is attached to them. So the first example of this is your serotonin. So serotonin is an important neurochemical, and this is your primary amines. Serotonin is an important neurochemical. This is your primary amine. So in this case, you can see there are two hydrogen atoms. Below you can see that there are two hydrogen atoms which are attached to it. So it means one is replaced by the whole alkyl chain. So its name is primary amine. So in the secondary amine, you can see that this molecule is having the two hydrogen atoms is replaced here. So here this is your this is your secondary amine, and in the third, in the nicotine, you can see that all the structures, all the hydrogen has been replaced. So this is your nicotine. So in the nicotine, you can see there this is a tertiary amine. So serotonin is a very important neurochemical, and the quinine is a poisonous hemlock, and nicotine is a tobacco. So here, these are the natural nitrogen compounds which are present or which are occurs in plant, and they are referred as alkaloids. So these are the alkaloid structures: serotonin, quinine, and the nicotine. So, IUPAC system. So, how can you nomenclate them? So, this is the nomenclature of the aliphatic amines. Here you can see in the IUPAC system, it is applying the following rules. So, here in the IUPAC system, applies the following rules to name amine. So, here firstly we have to pick in the structure the longest continuous chain of carbon atoms. So you have to pick the longest continuous carbon chain, and after that the parent name comes from the alkane of the same name number of carbon. So the parent name comes from the alkane of the same number of carbon. And here you have to change the E of the alkane to amines. So here we have to firstly we have to see that which is the longest continuous chain of carbon atom. Secondly, we have to name the parent name comes from the alkane of the same number of carbon. So next we have to replace this E from the amines from the alkane, and then after that we have to locate and name any substituent, keeping in mind that the chain is numbered away from the amine group, and the substituents which are attached to the nitrogen atom instead to the carbon of the chain are designated by the capital M. So here the substituents which are attached to nitrogen atom, they are instead of the carbon of the chain, they are designated by the capital N. So here you can see this is your methanamine, and the 1,1-dimethyl ethanamine. Third, this is your N-dimethyl ethanamine. So here you can see in the methanamine, the EA has been replaced. E has been replaced by your amine from the alkane, because methane name is your alkane name. So from the alkane name, this E is replaced by replacing it with the amine. So this is your methanamine. So this is the E of the alkane to amines. So here and second is you can see here its name is 1,1-dimethyl ethanamine. So here you can see there are two carbon atoms. There are two carbon atoms that are present, and there are two carbon atoms that are present, and there are two methyl groups are attached to this first carbon atom, which is attached to the nitrogen atom. So here its name is your 1,1-dimethyl ethanamine. So this name is 1,1-dimethyl ethanamine. Third is your CH3, CH2, and CH3, CH3. So on this nitrogen atom, this is your two alkyl groups are attached to it. Means here the two methyl groups are attached to this nitrogen atom, and So here its name is N means on the nitrogen there are two methyl groups are attached, that is why it is written N dimethyl ethanamine. So here you can see that the first methanamine is a primary amine because here two hydrogen atoms are present on this nitrogen group. So it is your primary amine. So in the second structure you can see this is also your primary amine because there are two hydrogen atoms are present with the nitrogen atom. And there is a third in this case, this is your tertiary amine because here no hydrogen atoms are attached and all the hydrogen atoms have been replaced by your alkyl group. So here the next is your CH3, CH2, 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 NH2. So in this you can see that you have to pick the longest continuous chain, which is the longest continuous chain. After that you have to name the parent name. So you have to just check that which is the this is which will come means here that 1, 2, 3, 4. 1, 2, 3, 4 means here that the 4 means your butane. So here you have to check the parent name means here the butane is the parent name that comes from the alkane and of the same number of carbon. So here there are four number of carbon atom present in this chain. So this is your butane. Okay, after that you have to replace E by the amine. So here we have replaced the E by the amine, that is your butanamine. And after that, if any other substituents are attached, then you have to name it away from the, then you have to number it away from the amine. And the substituents which are attached to your nitrogen atom, then you have to just named or designated by a capital N. So in this you can see the IUPAC name here that this is your here its IUPAC name is your 1-aminobutane. The IUPAC name is 1-aminobutane. So it is your 1 CH2 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 CH3. So it is your 1-aminobutane. Second is your CA name. So in the CA name, its name is butanamine. So in this, its name is butanamine because in this the butane chain is there and amine is attached to it. So its name is butanamine, and its common name is that N shows here a long chain of hydrocarbon, and butyl is the alkyl, and amine is your amine. So here its name is N-butyl amine. So second structure that is your CH3, 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 NH2. So here we are numbering it from the upside of the alkyl group that is attached because we have to check that which is the longest continuous carbon chain. In this, we are doing the CH3, 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 CH3. Then so here longest chain is this, that is your propane, and in this on the second carbon atom there is attachment of this amine group and the alkyl group. So its name is one primary. This is your primary amine because it is having the two hydrogen atom. One hydrogen is replaced by this alkyl group. So its name is your 2-amino 2-methyl propane. So on the second carbon atom here one methyl group is attached and one amine group is attached. That is why its name is 2-amino 2-methyl propane. Next is your 2-methyl 2-propanamine. So its name is your 2-methyl. So on the second position there is a 2-methyl group is attached, and on the second amine group is attached to here according to the CN name. We are naming it 2-methyl 2-propanamine, and next is the tertiary butanamine. Next is the primary amine. So in this case, you can see there is two hydrogen atom has been replaced by this alkyl group. So its name is 1-methyl aminopropane. So on the first carbon atom, there is an attachment of this methyl amine group. So that is why its name is 1-methyl aminopropane. It is a secondary amine. And on this N-methyl propanamine. So on this there is attachment on this on the N-methyl propanamine. So on the N position, the methyl group is attached and the propanamine. And there is 3 carbon atom, that is why its name is propane amine. and methyl propylamine. Now is your tertiary amine. So in the tertiary amine, this its name is dimethyl aminoethane. So in this, there are two methyl groups are attached to this nitrogen atom, or three hydrogen atoms. Three hydrogen atoms have been replaced by these three alkyl groups, and its name is dimethyl aminoethane. So here its name is dimethyl aminoethane, or you can say that N dimethyl ethylamine. So on the end, there are two alkyl groups are attached. So its name is N dimethyl ethylamine. Next is the ethyl dimethylamine. In this, the ethyl here it is in the chain, and dimethyl is two methyl molecules are attached to it, and this is the amine. So this is name is ethyl dimethylamine. Next is the physical properties and characteristics of amines. So the general features of amines is that the lower aliphatic amines are gaseous in nature with fishy smell. So here the amines, the lower aliphatic amines, they are in the state of gas, and they are having the smell that is a fishy smell. And the primary amine with three or four carbon atoms are liquid at room temperature, whereas higher ones are solid. The primary amines that are having three or four carbon atoms, means they are having three or four carbon atoms, and they are other liquids at room temperature, whereas the higher ones are solid at room temperature. Next is your aniline and other aryl amines are generally colorless, but they get colored if stored and open due to atmospheric oxidation. So these aniline and other aryl amines, these are generally colorless, but they get colored if stored in open due to atmospheric oxidation. So these aniline and the other aryl amines, they are generally colorless, and they get colored if they are colored, and if they are stored in open, they due to the atmospheric oxidation, they are they get colored. So means this aniline and this other alanine, they are colorless, but when they are stored open, so in the presence of the oxygen, or the due to the atmospheric oxidation, they get colored. Next, lower aliphatic amines can form hydrogen bonds with water molecule, hence they are soluble in water. So these lower aliphatic amines, they are forming hydrogen bonding with the water, and they are soluble in water because they are forming a hydrogen bond with the water molecule. That is why they are soluble in the water. These lower aliphatic amines. Next, increase in size hydrophobic alkyl part increasing the molar mass of the amine, which result in the decrease in solubility in urine. As the hydrophobic alkyl group is increased in the amine, so there is an increase of the molar mass. So there is an increase in the molar mass of the amines, and due to which there is a decrease in. So due to which there is a decrease in its solubility in water. So here, the lower aliphatic amines, they are forming hydrogen bonds. The lower aliphatic amines, they are forming the hydrogen bonds and the water molecules, hence they are soluble in water. But as there is an increase in the hydrophobic alkyl hydrocarbon chain, so there is an increase in the molar mass of the amine. So then the solubility with the water decreases. Higher amines are insoluble in water. Higher amines are insoluble in water due to the size of the alkyl part. They are soluble in the organic solvents like alcohol, benzene, ethers, readily to dissolve amines. So here, organic solvents like alcohol, benzenes, and ethers, these are readily dissolved amines, and the alcohol have high polarity as compared to amines, and hence they form stronger intermolecular hydrogen bonds. So these alcohols are having a high polarity as compared to amines, and hence they are forming stronger intermolecular hydrogen bonds. These alkynes, these aliphatic amines, they are forming, sorry, these alcohols, these are having the higher polarity as compared to amines. So they are forming a strong hydrogen bonding. Or you can say the strong intermolecular hydrogen bonding. So these lower aliphatic amines can form hydrogen bonding with water molecules and they are soluble in water. But as the size increases in the hydrophobic chain, this solubility decreases due to the increase in the molar mass of the aliphatic amine, and these higher amines, these are insoluble in water, and these organic solvents like your alcohol, benzene, and ethers, these are readily soluble, or you can say that these are dissolved in these organic solvents, and alcohols which are having a high polarity as compared to your amines, they are forming intermolecular hydrogen bonding. So primary and secondary amines are often engaged in the intermolecular association as a result of hydrogen bonding between nitrogen of one and hydrogen of other molecules. So the primary and the secondary amines are also engaged in the intermolecular association, and in as a result of which the hydrogen bonding between your nitrogen of one molecule and the hydrogen of the other molecule. It means there is an intermolecular hydrogen bonding. So they are also like the your alcohol. They are also involved in the intermolecular association. So the intermolecular association is more prominent in case of primary amine as compared to secondary with the availability of two hydrogen atoms. So there in the primary amine, there is the availability of two hydrogen atoms. So a uh, there is a intermolecular association. So there is more intermolecular association in case of a primary amine, but in case of compared to the secondary molecule, secondary amine. So in tertiary amine, there is no intermolecular association due to the absence of free hydrogen atom for forming. So in the tertiary amine, there is no association because there, as you know now, there is no presence of the hydrogen atom. There is an absence of free hydrogen atom for bonding. So these are the general features of amines which are showing the physical properties of amines. Next, this is the boiling point of amine is as follows, that the primary is having a higher boiling point compared to secondary and the tertiary. And this is the physical property of some amines and comparable oxygen containing compound. Like a butyramine, that is your primary amine, it is having a molar mass 73. Its boiling point is 78, which is miscible at 25 degrees centigrade. Next is your diethylamine, in which it is your secondary amine. It is having a molar mass 73. It is having a boiling point 55. It is miscible. Next is your butyl alcohol. And here alcohol is having a molar mass 74 and it is having a high boiling point. Its solubility is 8. Next, nine-diethylpyramines. In this case, it is a secondary primary amine and its molar mass is 101 and its boiling point is 111 and its solubility is your or 4. Next is your prime ethylamine. So in this case, it is your tertiary amines and this is having a molar mass 101 and its boiling point is 90. The solubility is 14 and the diethylpyl ether, so its molar mass is 102 and it is having a high boiling point. The solubility is 0.25. So all the three classes of amines can engage in hydrogen bonding with water, and amines are lower molar masses are quite soluble in water. Means the amines which are having the lower molecular masses, they are soluble in water, and the borderline of solubility in water is at 5 or 6 carbon atom. Means here that the amines that are soluble in water, which is having the 6 of 5 carbon atom in them. Next is the basicity of amines. So amines are basic and they possess a pair of unshared electrons which can share with other atoms. These unshared electrons create an electron density around the nitrogen atom. So this is having a lone pair that is present on this nitrogen atom and it creates an electron density around the nitrogen atom. So the greater the electron density, it means if the electron density is greater than the basic, the molecule is more basic. So it can donate the electron or supply electrons, which increase the basicity of amines, while the other, while groups that decrease the electron density around the nitrogen decreases the basicity of the molecule. So due to this property of an alkyl group attached to the nitrogen atom, the electron density around the nitrogen atom increases. Due to which, because their alkyl groups are the electron releasing properties. So due to the greater and easier release of electron in the alkyl amine, the molecule become more basic than ammonia. And whereas in ammonia, no such releasing group attached. So obviously, the basicity of ammonia is much less than that of the alkyl. So this is the basicity in the gas phase and the aqueous phase. In the gas phase, you can see, and in the aqueous phase, the difference in the basicity order of the gas and aqueous phase are the result of solvation effect that exists as ammonium ion. So in water, the ammonium salt of primary and secondary amines undergo solvation effect to which much greater degree than ammonium salt of tertiary amine, and these solvation effects increases the electron density of the amines nitrogen to a greater degree than the inductive effect of the alkyl group. So this primary amine is forming a primary ammonium salt, the secondary amine is forming a secondary ammonium salt, and the tertiary amine is forming the tertiary ammonium salt. Now the question arises if we compare the basicity of the aliphatic amines and the order of the basicity is not explain why. It is due to the steric hindrance and the solution of iron. So firstly, this unexpected order of basicity is due to the steric hindrance, and as the size of the alkyl group is more than the hydrogen atom, so the alkyl group would hinder the attack of a hydrogen atom, thus decreasing the basicity of the molecule. And more the number of alkyl group attached, lesser will be its basicity. So the decreasing order of basicity will be a primary amine, secondary amine, and the tertiary. Solvation of amine. When amines are dissolved in water, they form protonated amine, and also the number of possibility of hydrogen atom bonding also increases. More number of hydrogen bonding, more is the hydration, and there is a release of in the process of the formation of hydrogen atom. And more the hydration energy of the molecule, more is the stability of the amine. So the experiment shows here the hydrogen indicates in terms of hydration energy that the tertiary amines are more unstable as compared to the secondary amine followed by the primary. Means this tertiary amines are less stable followed by the secondary amine and then followed by the primary amine. So the number of hydrogen atom possible when primary amines are dissolved in water is the greatest, and the combined effect is having the plus I effect. And you can see here the secondary amine, then the tertiary and the primary and the ammonia. So now the questions. So nitrogen atom of the ammonia group is hybridized, that is your sp3 hybridized. How many structural isomers are possible for C3H9N? So the answer is A. C3H8N cannot represent partially ammonium salt. Identify the common IUPAC name. So here A. Correct. What is used in preventing the spoilage of olives and wheat? That is your A lactic acid. Which is used? That is your B. The amines which are bonded in alkyl groups are A primary amines. So the trimethylamine is an example of tertiary amine. So these are the references from where you can just learn this topic, the aliphatic amines. And thank you so much for today's lecture.